So I'll present on the topic of Internet of Things and AI, digital health at every doorstep. So first of all, I would like to give an overview and idea about our project, our work here in the center, with a little detail on one of our ongoing projects. Also, another thing I'd like to mention here is that, as the previous presentations has mentioned, all our projects are aligned with our motto, that is research for the societal benefit. Also, all the healthcare projects that we have are also in collaboration with the Amrita School of Medicine, Cochin. So, moving on to the setting the global context on hypertension, what we can see is that worldwide, if we take the worldwide population with hypertension, it's estimated to amount up to 1.13 billion people. And also, if we take the mortality that from stroke in US, that is what the hypertension leads up to, it's around 500,000 in number. Also, if we take the medication, the population that's taking the medication for hypertension, it's only 45%. And the blood pressure monitoring devices, the cost of these devices amounts up to $100 to $250 easily. And per year, in US itself, per year, the high blood pressure costs come up to $131 billion. So that's putting the context in the global scenario. Now, if we take our Indian perspective of this, 60% of the population has the hypertension, issue of hypertension. On that, 57 of them die due to series of stroke that's actually caused by the hypertension, and also 24 from the coronary heart diseases. And if we take the cost of devices here in India, it's around 3,000 to 13,000. And the population that's actually receiving the medication with respect to the rural area is only 25%, where the urban areas it's just 38%. And let's just look into the prevalence of hypertension in context. Let's just look into how are we monitoring the BP in the conventional way. So you must have seen these equipments at some point or the other, right? So here, what actually happens is the doctor, when you go to visit a doctor to take your BP, he actually puts a cuff around your arm and he inflates it, right? So when he is inflating this, it actually blocks your blood flow for a temporary period, and then it again he releases it and it again starts to flow. So he measures this time at which the blood flow stops and restarts, and that he measures with the stethoscope. So this is what correlates to the blood pressure values. So this is a device that is currently used, and the second device, also the digital manometer, is also now currently available and very popular, right? So that, and the third one is also a finger cuff device. So all these devices are based on cuff-based methods. So what the problem with these cuff-based methods are? Let's take a scenario where we are trying to monitor a high risk blood pressure patient. Okay, so in this case scenario, we'll have to monitor the patient continuously. We'll have to take the measurements repeatedly. So what happens is, when we try to take the measurements repeatedly using this cuff, one thing that can happen is obviously the discomfort that the patient will feel due to the repeated inflation and deflation of the cuffs. Another thing is that when you do this repeatedly, the blood flow is getting cut off from your arms for such a long period, and also in a frequent time interval. So due to this, there can also happen a condition where the oxygen supply is inadequate at those tissue levels. So this is not actually this is not recommended for a continuous monitoring. So in hospital, let's take the case in hospitals where a continuous evaluation would be necessary, especially in the case of ICU and invasive technique in which they can measure of BP with very high accuracy, but again that is not a portable or a method that we can easily implement. it comes with its own disadvantages, like those with the invasive techniques, that is probability for infection, or the expense of the devices that comes with the invasive techniques. The expense of these devices or the spare parts also comes up with this. So um, what we are trying to do is, we are trying to see where is a gap in meeting a continuous monitoring system, especially if we are thinking of deploying it in some remote areas, or if we are trying to make it accessible for everyone. So in this situation, we can see that these are the features that we are looking for in a continuous BP monitoring device. That is, it should be comfortable for long amount of time. There should be minimal to no medical supervision that is required, and the accuracy should also be there. And automatic storage of the data is preferable, because in this way, the doctor can analyze and see the trend of the patient's BP for a longer period of time. So he would be able to make a better diagnosis with this data, and also reduce the hardware complexity so that everyone can use this. So what we have developed here in our center is a non-obtrusive BP monitoring device using the technique of photoplethysmography. So the device that you can see there is the device that we have developed here. So there you can see that there is a clip that is attached to the finger of a patient. So this clip actually takes a signal from the hand, gives it to the device, and the device estimates the BP, and also send this data to a cloud, or store this data. And also this data can be accessed using a smartphone, the app installed, since the smartphone is also connected to the device with a Bluetooth. So in this way, we are able to easily use a device that is designed to be non-invasive, with no medical supervision, that has a data storage feature given to it, and with a reduced hardware complexity. So our aim is to give it in a low cost. So taking this to the next step, what we have done is we have integrated other vital parameters also to this device. That is, we have integrated SpO2, that is the oxygen level, pulse rate, and the respiratory rate with the same device. So you don't have to buy a number of devices to find different measures. You can just use one device, and you can get all these four parameters, four vital parameters in that device, with that device itself. So that is what our aim is. And you can see that, and you can see the app there. So this is a screenshot of how our app looks in the smartphone. So all the estimations. So we have told that we are estimating BP, oxygen, pulse rate, respiratory rate. So all of these are done using the machine learning techniques, the AI techniques. So we are implementing them to find these vital parameters. So this is an architecture of how our system works. So this is backed by the Internet of Things technology. So here the user device, this is our device that takes the data, and then there is a processing unit which processes the signal. And when the model outputs the value of your BP, of the corresponding BP to the signal it received, it can produce an alert if the value is critically high. For the high-risk patient, if the value crosses a threshold, if it's a critical value, then it can directly alert the hospital or the caretaker or the doctor that is in charge of that patient. If not, it can also go onto the cloud or the storage location, and then we can use it to predict if there is any condition that's going to happen, or do another level of analysis with the same data itself. So this is a very rough picture of what our device does, and how the Internet of Things technology and the AI technology is combined to achieve this. Another aspect of this that I would like to share is how we have deployed this project. So as part of this project, we have taken data from, or we have deployed this on more than 500 patients. And these 500 patients also include the people from the villages that we have adopted. So we have the data from people of the villages from Wayanad, and also data from the hospitals, Amrita Institute of Medical Science. We also got the data from the patients over there. So that's about how we have deployed. Another aspect that I would like to mention is that for this device itself, we were able to get 2 patents for this, and also we were able to bring in collaboration also. So there were students interning with us that had come from the University of Buffalo and EPFL, and they were able to come here, participate in our project, and work closely with Amrita here. So that's about the outreach and what we were able to deploy using the products that we were able to come up with. So that sums up our research and gives a glimpse into what we are doing here. So thank you, Nasha.